Hello again. In this video, I'm going to show how to create a library for a neural network. I've written before a library for neural network in C, but it was a long time ago and I don't really remember. I'll try to do in this video. Also, I won't show all my thinking process, but I'll cut out the parts where I'm thinking too much. So let's get started. Here I'm going to create a folder for the library. It's going to be, I'm going to call it MLP core for multilayer perceptron. And then we're going to have a directory full of source files for tests and for the build output. And then the source files, we're going to have like two files. Let's call it MLP core.c and MLP core.h. And let's create a test also. So tests 01 for now, that's it. And we need to create a build script. So let's do this. Let's do this in bash. But in the future, I'm going to write maybe a make file or a maker. I don't know yet. So let's start with the build script. As I said, it's going to be a bash. Let us define the compiler, also some flags. I'm going to use all the warnings and enable the extra warnings. Also, I believe maybe f-analyze. Okay, now let us do G3 and OG for optimize for debug. Okay. So what do we do now? Let's call C here with all the warnings, all the C flags. Let's first compile the library. Let's use it's going to be a shared, and also let's do the output is going to be in the build. Let's call it libmlp core.so. And then let's compile the test. Let us do like test 01.c. Then we have to link with the build. don't know. I don't remember if I use -L. So I believe it's lib MLP core. Maybe I don't know if I have to put that as so. Okay, and the output is going to be in build also. Test 01 dot. Oh. Also set -x. Okay. Okay, let's try now to open okay, let's try now to open the no, there's a problem with the flags. Let's okay, now the flags are okay. So let's open now the library. And let's open the test. Let's start with the test. Okay, so always have to have a main file. And 0. Then we can have, let's define here the header file mlp core 8. Okay, so let's first define a struct because we need it. So let us do this with a type def. Let's call it the struct. We can call this like it's a multilayer perceptron. We can call mlpt. Okay, and then we can have like our can have size C. We have to define the number of inputs, the number of outputs, and the number of layers. Okay, what more do we need? We need to include this. So include the standard lib.8. What more do we need? We need the number of weights and the number of biases. Although the number of biases is equal to the number of neurons, so we can like use a union here. Okay. I see, and then the number of biases is equal to the number of neurons. What more do we need? We will have to allocate some pointers. So we must also have the layer shape. So let's see, let's use a pointer, layers shape, and we need like pointers for the weights of the biases. One more, we need pointers for the biases. We need pointer for the sums. We need pointer for the outputs. Okay. And like we need pointers for the activation functions. So because each neuron will have an activation function, so let's define also an activation. And there are like, can have a step, the first activation T, let's call it. So also need activation T, let's call it activation of this array, this pointer. And then we have to initialize all of this in the .c file. So in the test, we're going to create first. Like, let's include first. Okay. Let's use here the following. We have to define an MLP, multilayer perceptron. We will need a shape, so size T. Let's call it only shape. Maybe in the future, I don't like this implementation because I need to get the number of the shape, the number of layers. So like if I have two inputs, I can have two hidden, one hidden layer with two neurons and one output. What more? I need to get the number. Okay, I need to get the size of this. Let's define. I like to use capital letters for markers. Let's call it size of array. This will give me the size of the array in bytes, and if we divide for the first element, we will have this is a const, I won't change this. So also another const. Let's call it size CN layers. I don't know if this is going to work. So let's call it array length and pass the shape. Okay, that's it for now. Let us see if we can compile this. It probably won't work because of the link. Okay, it works. Unused variable. Okay, unused variable. Okay, so for now, let us go. We have to define a function now to initialize our multilayer perceptron. So here we also have to include the header. So MLP core. Let's call it. Maybe it can return. We need a function to configure our perception. So let's call it MLP config. So I can pass a pointer to my MLP. Also, I need the layers shape. Layers, let's call it layers shape. I'll size see any layers. What more? I think the activation maybe. Okay, let's pass also the activation. Activation T, activation. I like to return a status. Let's call it int status equals 0 for now. Okay, and this we have to call it to declare in the header file. So let's define it here. So the first thing we have to do is verify if the arguments are correct. So if MLP is a null pointer or layers shape is a null pointer, we have to maybe we can print some error here. F. Okay. Standard IO. Let's use standard IO. Let's use print to standard error. And the message maybe. Null pointers best. Let's use this for now. We can maybe set a status here. Like maybe we could use or no. Okay, it's an invalid argument, so plain inval. So go to maybe like let's call it exit. Okay, exit. Okay. What more do we need? We need to verify the number of layers. It should have at least the input and the output, so it should be at least 2. If n layers is less than 2, let's copy this. Let's call it, and layers must be at least 2. Okay, now we can initialize our function. We can use the things that are necessary. Okay, I think we have to allocate memory for the weights, the biases, the sums, and the outputs. Also the layer shapes. So let us do the following. You have to get first the number of weights. So let's define here IC and weights equal 0 and size C and biases equal 0. So we're gonna have to loop through the layers shape. So let us do. Let's call it size C. We can start, I believe, from the we can start from index 0. I have a picture I'm going to show you. I'm trying to find it here first. Okay, so I have this picture here. It shows the layers and also the neurons. In the input we have 2 inputs. We have one hidden layer with 2 neurons, and the output have 1 neuron. So we can see here that the number of biases is equal to the number of neurons. Like for each neuron we have 1 bias. And how do we get the number of weights? The number of weights is the following. Like here we have two neurons and 2 inputs, so we can multiply. It's because for each neuron we have 2 inputs here in this case. So 2 times 2 neurons, it's equal 4. In the case of the output, have like 2 inputs also, but only 1 output, 1 neuron. So 2 times 1, 2. I don't know if that is clear, but that is not the objective of this video, so I'm not focused on that here. Let's continue. Let's start with I from 1. And let's loop until the number of layers minus 1. And we can do like this. The number of weights is equal to the layer shape is equal to the number of neurons in this layer, so I have to call it, times the number of neurons in the previous layer. So it's layer shape times I minus 1, layer shape of I minus 1, and the number of biases is equal only to the layer shape of I. Now we can allocate the memory for the weights for the neurons. Let us start. Layer MLP layer shape is equal to, we have to call malloc layer shape. Here's the number of layers. And then we should do this. The size of an MLP layer shape. Okay. I'm going to try to allocate everything, and then in the end I'm going to verify if everything was allocated successfully. So here is a pointer. Oh, I forgot that. Oh, sorry. It's already a pointer. I don't need to do that. Okay. Double. So MLP weights. What did I forget? Expected the end of the declaration. Yeah, this. Okay. What more did I forget? Oh, sorry. I used this. I'm so sorry. Okay. Let's call malloc here. Now the number of weights times size of MLP weights. I'm so sorry for that, guys. Had to allocate, so we have to verify now if this was allocated successfully. So we have to verify layer shape is no or MLP. Okay, and then we're going to do something like this. So, but if it failed to allocate, we can say that there was no memory. So no memory. Okay. It was not possible to allocate memory, something like this. But we have now to free this memory. So we're going to need another function. Let's call it, it's a void function. MLP deconf. And then we're going to receive a pointer to our multilayer perceptron. Let's see. And let's declare this in the header file. So yeah. Okay, we can do. We have to declare them. We have to free them. We have to free each one of them. Okay, let us do this. So let us free this memory. LP layers shape. We should now clear our pointer, our MLP pointer. So we can do like mem set MLP, but I never remember the syntax, so let us do something like this. Mem set. Okay, let's see. Int C is the byte that we want to set, and S in what is N? The first N bytes. N is the number of bytes. Okay, so right, let's set it to 0 and size of MLPT. Okay, but we have to import the string library, so here include string delete. So now that is okay. Okay, and before we do this, we should before we exit, we should call MLP deconf. We call here our MLP. Okay, that's it. But if everything is okay, we can now set MLP in weights to n weights, MLP in biases to n biases. Something more that we should do. We also have the activation, so MLP. Oh, we forgot to allocate the memory for the activation. So activation. So MLP activation malloc. Also the number of biases, because it's one activation for each neuron, times size of MLP activation. Also have to verify whether it was allocated. MLP activation equal no, and we have also to free here the memory. So MLP activation. Okay, that's it. Is there something more? Let us see. Next, about the number of layers I need. MLP n layers equal to n layers, and we need to also copy the layer shape. So let us do like mem copy. I also never remember this, so mem copy. We need to so the destined buffer is MLP layers shape. Source is the layers shape. The size n is the number of bytes. So what's the number of bytes that we need? It's n layers times what? Okay, we can do n layers times size of MLP. No, let us do size of layers shape, and I believe that's it. So let us verify. I set the number of inputs. I didn't set the number of inputs. Okay, proof of false. We also have to set the number of inputs, the number of outputs, and inputs is equal to layers shape 0. MLP, the number of outputs, layers shape and layers minus 1. Okay. Inputs and outputs, number of layers, number of weights, number of biases. Okay, I believe that's okay. So let us call this here. Let us set a status here, like int status equals 0. LP conf. Okay, then we have to pass the pointer to our multilayer perceptron struct, our layer, our shape, the shape of our perceptron, the number of layers, and the activation that we want. What do we want? We only have a step, so it's a step. And let's restore the status at the end. So okay, it complains here because I pass a const size C3. So okay, let us do the following that I like to do. I always like to do this, like I like to declare here as a const, here as a const, also here as a const. It's also a const. So we have, let's copy this to the header file. Let's paste it here and delete this. Okay, this is still complaining. Okay, proof of false. Also, maybe we could set the following because this is also a const. Okay. So now the warning is gone. Okay, can we get rid of this? Okay, now it works. And at the end, we can't forget to also deconf our file. So conf MLP. But it's a pointer, so that's it. Okay. Let us see if this compiles first. Okay, it compiles. Where do I have an unused variable? Okay, I still have to copy this activation function. So let us do that. I forgot that. Also need another memory copy here. We allocated the memory for the... let me close this. Okay. We allocated the memory for the activation, but we didn't copy that. So let us do memcopy mlp activation. It's not being memcopy, it's memset. The source is mlp activation. For now, the value is going to be activation, and the number of bytes that we need is going to be number of biases times the size of MLP activation. So let's try to compile now. And it compiles, although it could not link our library. So let us do this. I never remembered this. Do I have to call .so? It's not possible to locate and leave in before. So finally, guys, I discovered the problem. I knew something was wrong with linking the shared library. So the problem is this: we have to use -L in the folder that is going to look for the library, then -l for and then the number of the library, the name of the library, that is MLP core. And this was the problem. So when we run here, it compiles fine. So let's try to run. So here we are loading shared libraries. Cannot open shared library no such file or directory. So let's try to fix that again. At least we call libmlp. Okay, guys, after some search, I found out what I did wrong here. It is the following. I had to add this here in the build script, and also the L./build and small l MLP core. I had to add this to make it work. So when I try to compile this, it works. And when I try to run, it also works. Okay. So we can see if everything is okay. Let's open this and try to debug. Okay. Page name. let us see. Yeah, run. Next, we can see, for example, MLP. So we have like a lot of things here. You can see that it's a lot of garbage inside MLP. So let us see at the end. So print now MLP. MLP. So we can see that it has 2 inputs, 1 output, 3 layers, and weights, and like 4 weights. Is that right? That is totally wrong. The number of weights is wrong. The number of biases is right, and the number of neurons is right. And it was able to allocate all the things. Then let us see if it was able to deconf our struct. Yep, that is right. Okay. Yes. Let's try to fix the number of weights now. Why is the number of weights wrong? It should be 6 and not 4. So why is it wrong? Let's find out. Oh yeah, I know now what is wrong. We have to look until the last layer. So let's try to recompile this now. And then let's debug it again. Main run next. Now let us print MLP. So the number of layers is 6, and also the number of biases is 3. I said it was 2. The 2 was right, but no, it's 3, the right number. Okay, that's right. Let us step again and print again. So everything is okay. Yes. We should create a function to perform the feedforward part and then test our library. So let's implement it here. Okay, so MLP feedforward LPT. Okay, I pointed to my multilayer perceptron struct. Maybe I should have we have an array, because I'm going to open that image again. This image, we have an array with inputs. Okay, and also we should pass an array to get the outputs. Not. Okay, maybe yes. Okay, let us do this. One array for the input, an array for the output. Okay, let us do this. So here, let us do double pointer inputs. Okay, and also double pointer to the output. Okay, and also have a status. Okay, then we have to test if they are valid arrays, valid pointers. So let us do this. LP equal no, or input equal no, or output equal no. So let's get this. Pointer passed. We'll next it go to exit. Okay, this is going to. I believe we should look through the layers and get the outputs and multiply both the inputs and multiply them by the weights. So let us do something like this. Okay. Layer. We're going to start with layer 0 and then layer. We'll go into the last layer. MLP. Any layers? Any layers? Okay. No, it won't go to the last layer. It will go to the second to last. So okay, what do we do now? And then for each layer, maybe we should loop through the neurons. Okay. Like one neuron and layer. And then neuron layer. This we have to do until the last neuron of that layer. So MLP layer shape layer. Okay. And then I want to write neuron layers big. Only neuron. Okay. What do we do now? I'm going to have to think now. Maybe we should have a pointer to the input of each layer. Okay, so let's declare here. Like let's initialize it with the input. Okay. And then at the end, always going to update. Like so x is equal to MLP. Okay, outputs. Okay, the false. but I have to sum something here. X, let's call it X displays. Let's call it size T X displays. I'm not going to initialize it now, or maybe yes. Let's start with 0, but we have to update X displays. What is X displays? First, I don't like this number. First, I don't like these outputs. Let's call it results. So let's substitute this like outputs. Let's call it results. Yes, yes, yes. No, number of outputs is the number of outputs. Okay, yes, yes. Okay, but now there is no menu. Let's rename it here outputs. And okay, I still have to solve this, but how much X has to display. So let's open the figure again. So if I'm here now, if I want to come here, I have to sum the number of neurons here. So that's it. So NLP layer shape, the number of the next layer. So layer plus 1. Is that right? I believe so. Now we have to implement this first. We have to multiply this array with this one here. So maybe should have a function to do that. Let's do this. Void. It's a dot product. It's like a dot product. Let's call it dot product. Okay, what is it going to receive? Oh, it has to return a double. Let's also declare it static inline. Okay, what do we do here? We should receive the X, do X, and for V1 vector 1, double vector 2, and also the size. Let's return result. Let's do the following. Okay, result is going to be, we have to sum the result, so it's going to be V1 times V2. Okay, that's it. I believe so. So let's call it here, down here. So MLP hopefully the compiler will optimize this variable out. So let's call it dot product. Let's pass the first. Okay, it's the number of weights. Okay, let's first pass x. We have to pass the weights. Okay, let us do this also. The number. Layers, shape, layer. Let's call it only sum. Okay. Temp sum. We have also to define. I need an array for the weights. So let's define it here also. I know that weights, this point is going to start with weights, MLP weights, and at the end of each iteration here I will have to sum it with something which is that I see. Like I have a pointer to this first weight. If I want to get this to jump to here, I'll have to sum the number of inputs. Okay, so it's going to be MLP layer shape layer. I think that's it, but always at the end I do this, and this is the sum. What do I do with the sum now? I do the following MLP sum neuron, and then I have to go to the specific neuron, but it has to be a global neuron, so let's also define it here. Neuron global. Start with 0. And then neuron global. At the end, I have to update the index. So we do this global temp sum, and also we have to update the results. So MLP dot results also neuron global, and then we have to apply the activation. We're going to need a function for this. Let's do this now also. Okay, let's call it activate. It's also an inline function. Static inline double activate, and then it will receive a value. So we double, let's call it x. But it also has to, it is specific to the activation. So activation. So let's come here with activation. But I have only one, so step. Let's define it here for double results. 0. Okay. And then step is if it's greater than 0 is 1. Okay. So this is the following. I have to ask greater than 0. It's a question. So return 1. Otherwise return 0. Okay, and return result. That is it. So let us call it here. We'll activate. And then we have to pass the sum and also the activation MLP activation neuron global. Okay. And at the end, we have to copy the values of the results to the output. So copy the descent is MLP. Okay, MLP. It's not MLP, it's output. MLP dots results. Okay, then we have to get the number of neurons. So MLP. Okay, I'll have to declare it here so that it's not a big expression. Layers. So MLP. It's not in layers, it's any neurons. Neurons. Outputs. So MLP any outputs. So in neurons minus any outputs. Okay, and the number of outputs, I believe, any outputs inside of MLP results. So what is wrong? No member result. because results. Okay. Outputs. And neurons. Double. Yeah, and here's a point. I forgot that. So now we have to test this. Okay. I'll open the internet and look for some values for neural networks for like an XOR or NOR, an AND gate, something like that, and we'll try to implement it here. Okay guys, I searched the internet and I found some weights for the XOR logic that it basically works as when the two inputs are equal, like 0 and 0 or 1 and 1, the outputs here the output has to be 0. And when the inputs are different, like 0 and 1 or 1 and 0, the output has to be 1. Also, I got the weights and the biases. The weights are almost all equal to 1, except the index 4, it's -1, and the biases it's minus 1.5, minus 0.5 and minus 0.5. I also wrote this here to verify the behavior. We're going to loop through each sample of the input and call the function feedforward and get the output here in this variable called output. And then we're going to print the result. We're going to print the inputs, the output that we get from our neural network, and the expected output to see if everything is alright. So let us see if it works. Let's first compile. Okay, there are some warnings that I'm going to solve later. Let's run. Okay, we have some errors here. Let's try to debug this. It's here. Break in main. Okay. Run. Okay. Break library. Let's try to run again. Next. Where is happening this? So it doesn't seem like it's inside. Let's refresh this. Next, it doesn't seem like it's inside the for loop. This is the last output. So it's when okay, but something is happening. Okay, even though the problem is happening here, it is because something is corrupting our perceptron struct in this feedforward, because we tested this conf. I believe that's it. So let us do this. Let us verify what's happening. Oh, I forgot to mention that I included the prototype of this function in the header file. Okay, first let me see what's happening. We're going to loop through each layer, and for each layer we're going to get the number. Okay, but the first layer doesn't have any, we doesn't have any neurons, so we're going to loop here. Let us see if this shows something. So we don't start in the first, let me open this again. We don't start in the first layer. We start in this layer. This one has neurons. The input layer doesn't have neurons, so okay, let's try to compile this. Okay, and run. Okay, no, I don't want this. I want it to run. Okay, it doesn't crash anymore, but we don't get the expected output. So what is the problem now? Okay, we make the dot product. Okay, I forgot to sum the bias. So let's sum the bias here. Plus MLP biases of this neural global. Let us see if this works now. Let's try to compile and run now. Okay, it works. Okay, I believe that's it, guys, for now at least. We have yet to clean some stuff here, but I'm going to do in the next video. And I also have to implement the backpropagation here, and I'm going to do that, but this video is already too long. I'll try to cut out the necessary things and go straight to things. I don't know if I'm gonna put the mistakes. Maybe I'll cut them out. But that's it. Stay tuned. The next video I'm going to implement the backpropagation, and then we're going to clean all this thing. Okay, so that's it, guys. Until the next time.